Graphing equations in the coordinate plane. In this video, we'll describe the coordinate plane, label the x and y axis, and find points and their coordinates. We'll make tables of solutions to equations in x and y, and then we'll graph the equations from those tables. I'm going to review briefly graphing in the coordinate plane. We have two number lines, or axes. The horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Every point in the plane has two coordinates written inside parentheses and separated by a comma. The x-coordinate always comes first. It's where the point lines up with the x-axis, in this case, -3. The y-coordinate comes second. It's where the point lines up with the number on the y-axis, in this case, -1. If I reverse the two coordinates, I get a different point because x always comes first and y always comes second. So this point, -1, -3, lines up with -1 on the x-axis and -3 on the y-axis. If a point is on the x-axis, like this one, the x-coordinate is 3, but the y-coordinate is always 0. It lines up with 0 on the y-axis. If a point is on the y-axis, its y-coordinate is the number that it's on, and its x-coordinate is 0 because it's lined up with 0 on the x-axis. This point at the center has coordinates 0, 0 because both x and y are 0, and it's sometimes called the origin. Mathematicians use graphing to visualize a relationship between x and y that's usually given by an equation. For example, if y is 3 more than x, I have an equation that says y equal x plus 3. And I can graph that relationship. For different x's, I find the y. No matter what x I choose, I can find a y that is 3 more than that x just by adding 3 to the x. So -4 plus 3 is -1. -2 plus 3 is +1. 1 plus 3 is 4, and so forth. When I make a table like this, I have an x-coordinate and a y-coordinate, and I can graph those points that I've found. The points that I've found are not all the possible solutions. I've just found a few. -4, -1 is one possible solution. -2, 1 is another solution. And 1, 4 is yet another solution. There are fractions on the number line, so what if x is 1/2? Well, y must be 3 more than 1/2, or 3 1/2. So I have another point right there. Well, I could keep doing this all day. There's infinitely many numbers on the number line. So to make my graph show all the solutions, I can connect the dots, so to speak, and every point on this line is a solution to the equation y equals x plus 3. So I can randomly choose any point I like. How about this one? Well, x is -5. -5 plus 3 is -2. And so this point, -5, -2, is also a solution to the equation. The trouble with graphing with tables is first that it's rather tedious. I have to choose a large number of values of x and then plug those x's in and evaluate what y is for each one. Why don't you pause and try that yourself, and then I'll fill it in so you can see what happens. Check your table against mine, and now we'll plot those points. Well, here they are, but what about in between? How can we fill in the shape of this graph? There's many choices. For example, what if it goes curvy up and then curvy down? It could even swoop down here and then come up here and then come around there like that. We don't know without filling in the intermediate points. And that's even more work because they're fractions. Well, the way we learn to do it later is to recognize a type of equation and understand what shape that type of equation has. In this case, I know that the absolute value of a plane x not to any power will make a V shape, and so I can connect the points with a V. We'll learn to graph many different types of equations and to find important points on those graphs, like the point 0, 3 here where the graph turns around and goes back up. Remember that when you're graphing, you're trying to show a picture of a relationship, and so you can choose where you put your axes so that you can see that relationship clearly. So in this case, I'm going to find out what points I need to plot first and then adjust my graph so that I can fit them on. I choose points for x that are near the origin, and then I calculate the values of y by plugging in the different x's. Pause now and do that for practice. And check yourself against my chart. Now it looks like I have to graph numbers as high as 12 in order to get something as small as -3 on the graph. So I'm going to adjust my axes so I can fit points as large as 12 on the y-axis. The x-axis goes through 0, and I'm going to count by 2's again so that the units match on both axes. Now when I plot these points, -3, 12, -2, 7, -1, 4, 0, 3, 1, 4, 2, 7, and 3, 12. I have another shape. Looks kind of like it did before, a V shape. But in this case, because it's an x squared, these aren't straight lines. Again, we have to learn the different types of graphs to really graph efficiently. So when I connect them here, I'm connecting them with a curve. This curve is called a parabola. It keeps going up like this. And we've plotted points on it, but it's hard to tell just with the table what the exact shape is. So I hope you're inspired to learn the different types of graphs